Hello, Dan Nadelkowski here from howtomechatronics.com. In this Arduino tutorial, we will learn how to make a wireless communication between two Arduino boards using the nRF24L01 transceiver module. For explaining the wireless communication, we will make two examples. The first one will be sending a simple Hello World message from one Arduino to another, and the second example will be a bidirectional communication between two Arduino boards, where using the joystick at the first Arduino, we will control the servo motor at the second Arduino, and vice versa, using the push button at the second Arduino, we will control the LED at the first Arduino. Now let's take a closer look at the nRF24L01 transceiver module. It uses the 2.4 GHz band and it can operate with baud rates from 250 kilobits per second up to 2 megabits per second. If used in open space and with lower baud rate, its range can reach up to 100 meters. This module can use 125 different channels, which gives the possibility to have a network of 125 independently working modems in one place. Each channel can have up to 6 addresses, or each unit can communicate with up to 6 other units at the same time. The power consumption of this module is just around 12 milliamps during transmission, which is even lower than a single LED. The operating voltage of this module is from 1.9 to 3.6 volts, but the good thing is that the other pins tolerate 5 volts logic, so we can easily connect it to an Arduino without using any logic level converters. 3 of these pins are for the SPI communication and they need to be connected to the SPI pins of the Arduino, but note that each Arduino have different SPI pins. The pins CSN and CE can be connected to any digital pin of the Arduino board, and they are used for setting the module in standby or active mode, as well as for switching between transmit or command mode. The last pin is an interrupt pin, which doesn't have to be used. So once we connect the nRF24L01 modules to the Arduino boards, we are ready to make the codes for both the transmitter and the receiver. First, we need to download and install the RF24 library and make sure you have the correct one. You can find the download link on the website article. So we need to include the basic SPI and the newly installed RF24 libraries and create an RF24 object. The two arguments here are the CSN and the CE pins. Next, we need to create an array which will represent the address or the so-called pipe through which the two modules will communicate. We can change the value of this address to any 5-letter string, and this enables to choose to which receiver we will talk. So in our case, we will have the same address at both the receiver and the transmitter. In the setup section, we need to initialize the radio object, and using the radio.openWritingPipe function, we set the address of the receiver to which we will send data, the 5-letter string we previously set. On the other side, at the receiver, using the radio.setReadingPipe function, we set the same address, and in that way we enable the communication between the two modules. Then, using the radio.setPA_level function, we set the power amplifier level. In our case, I will set it to minimum value, as my modules are very close to each other. Note that if you are using a higher level, it is recommended to use bypass capacitors across the ground and the 3.3 volts of the modules, so that they have more stable voltage while operating. Next, we have the radio.stopListening function, which sets the module as transmitter, and on the other hand, we have the radio.startListening function, which sets the module as receiver. In the loop section at the receiver, we create an array of characters to which we assign the message Hello World. Now, using the radio.write function, we will send the message to the receiver. The first argument here is the variable that we want to be sent. By using the ampersand before the variable name, we actually set an indication of the variable that stores the data that we want to be sent, and using the second argument, we set the number of bytes that we want to take from that variable. In this case, the function sizeOf gets all bytes of the string text. At the end of the program, we just add 1 second delay. On the other side, at the receiver, in the loop section, using the radio.available function, we check whether there is data to be received. If that's true, first we create an array of 32 elements called text, in which we will save the incoming data. Using the radio.read function, we read and store the data into the text variable. At the end, we just print the text on the serial monitor. So, once we upload both programs, we can run the serial monitor at the receiver and we will notice the message "Hello World" gets printed each second. Next, let's see the second example. Here's the circuit schematic and now we will take a look at the Arduino codes. What's different here from the previous example is that we need to create two pipes or addresses for the bidirectional communication. In the setup section, we need to define both pipes and note that the writing address at the first Arduino needs to be the reading address at the second Arduino, and vice versa, the reading address at the first Arduino needs to be the writing address at the second Arduino. In the loop section, using the radio.stopListening function, we set the first Arduino as transmitter, read and map the value of the joystick from 0 to 180, and using the radio.write function, send the data to the receiver. On the other hand, using the radio.startListening function, we set the second Arduino as receiver and we check whether there is available data. While there is available data, we will read it, save it to the angle V variable, and then use that value to rotate the servo motor. Next, we set the first Arduino as receiver, and with an empty while loop, we wait for the second Arduino to send data. And that's the data for the state of the push button, whether it is pressed or not. If the button is pressed, the LED will light up. So this process constantly repeats and both Arduino are constantly sending and receiving data.